of QGIS for this FDP is the very reason is nowadays as geospatial technology has become very essential for all the domain engineers or all the modern engineers. So that has set a context and uh, to deliver or to choose this topic. So there are we know there are different geospatial technologies which includes GPS, remote sensing, and GIS. So this geospatial technologies using this, so we could able to do the data acquisition in a real-time basis, and also we'll do the better analytics over the data that is collected, and also we can able to visualize the data. So this is our outline of the presentation. So we'll have a short introduction about GIS, what is GIS, and then also about QGIS, and of how this QGIS is useful in our civil engineering domain. So that we'll discuss. And of course, I will discuss about the digital twin with GIS, wherein we will discuss how this BIM, this building information modeling, could be clubbed with GIS. So when we are doing this, clubbing, like how it's going to be helpful for the better resource management, better infrastructure development, and all that. And also, I'll do a quick walkthrough of QGIS interface. And also, I'm going to do a live demo on a few case studies that I've chosen. That's one. The first case study will be on extracting the building footprint, okay, in the given area. And then also there will be a case study, the interesting case study to identify the forest fire that happened in the Los Angeles area, okay, in the US. So this is going to be the presentation flow. Okay, to get started. So the QGIS, which stands for Quantum Geographic Information System. So this is basically an open source geographic information system software. And this basically, the GIS means it's where we handle the geospatial data, right? So this data could be about spatial, dominance about the spatial information. And also, of course, we'll have an attribute data as well, like about the location. And say example, if you're going to add, in any of the locations, if you're going to about Chennai. So within Chennai, if I'm choosing something like a Punnamalli, if I'm choosing. So for Punnamalli, to know its proper location on the map, we'll have a latitude, longitude. That's your spatial data. And maybe for Punnamalli, how much of population is there, okay, and other details, how much of the area is there. And then how large it is, the extent of the area, and then what is the other extent land, what is the industrial population in that locality. So all that will be like a attribute data. So this QGIS, which provides a powerful and user-friendly platform. So to work with the geospatial data, wherein you can also include your attribute data. So together that will give you the better output or better visualization. So this QGIS is which enables the user to analyze whatever the data that you feed, and to visualize is better, and also to manage all this spatial informations very efficiently. So that's the advantage of having this QGIS. So other benefits, if we want to list, so basically it's open source software. You don't have to pay any money for licensing. So you can use it wherever you want it, and for the unlimited time you can use it. And then it's a user-friendly interface basically. So wherein the toolbars and other interface will be, it doesn't make you feel complex, to understand or to work with. So it's basically a very, it's almost like a CAD, AutoCAD software, whatever we have been using in our civil in the basic level. So it almost, the interface would look like the similar. The menu bar will have a toolbar and all that, and status bar and all that. So, and then the versatility in handling the data. So basically, the QGIS will have two type of data. One is the vector data, other one is the raster data. So the vector data, wherein which includes your the points, lines, and polygons, and the raster data would be like the satellite imagery and then digital elevation model data and all that. So we would be handling we would be able to handle all this data together efficiently. Like, so that's another benefit, and then it's a powerful analysis tool. So why we say it's a powerful analysis tool? Because you can work with multiple layers, okay, and also you can upgrade whatever the, suppose if you wanted to add I mean update the feature in the given area, okay, in the geospatial context, so that you can do it with help of this QGIS. And also I would be able to do the map creation and the visualization, which means the map creation in the sense, often when we do some research work, we create a study area map. So that's a basic level to tell you, like study area map, we will be able to create it within 30 minutes of time with all the geospatial information very accurately with the help of this QGIS. And also you can visualize whatever the data that you feed in. Suppose if I wanted to know the population of the entire Tamil Nadu district-wise, I would feed the data of Tamil Nadu with all the district name and what are the population, gender-wise, and all that. So this data will be fed into the QGIS platform and will give you the diagrammatical or graphical view of the population statistics across the districts. So, so this is how this QGIS tool that can be done easily with the help of the QGIS. So this map creation and visualization can be done better. And then data editing capabilities. So you can work with, you can edit the data, okay, the multiple levels, right? And then the plugins and extensions. Another, advantage of having this, QGIS is, this QGIS offers the plugin architecture to allow to extend functionality other than its basic, the architecture level. So this you have 1,000 plus plugins within this QGIS you can use, or you can download and install, and you can work with. So which will give it a better visualization or better analyzing capability, or which would extend the capability of QGIS further. So then we don't get this much of flexibility in doing with other paid softwares like ArcGIS and all that. Of course, ArcGIS has its own advantages, but being it's open source, I would say this it offers multiple avenues to work with different plugins within. And then also we have active community support. You may think it's an open source software. We may have a limited feature to work with, but that's not the case. There is a limit. There is an active community who's working in the back end. So they do fix all the bugs whichever develops within the software often, and also they add a lot of features within. I mean, they usually upgrade. Maybe in the due course I'll show you the website also. So there will be every month or and often there will be a release or upgraded versions that will be released in the QGIS. And also it's very flexible to use with a different operating system, whether it's a 32-bit or 62-bit, or if it's a Windows, or if it is a Linux, or if it is Apple iMac. So of course you can install the software to any of the operating system that you use. Okay, it has that diversity, or it has that versatility to work with. And then the data integration and visualization. So data integration and visualization in the sense, you can, as we're going to discuss this BIM and GIS, so that we'll see much about this. And then effective decision making. Of course, adding all this data and visualizing, working with all this and editing all this would give you the better output. So using that output, you will be able to do the effective decision making. Maybe that is in the real time sense. Maybe if I have some flooding, there is some natural calamity that's happening, there is some landslide that's happening. So for all this, okay, we need a effective decision making, and that should be in a swift manner. So that can be done with the help of this QGIS. So these are the benefits of QGIS. And then the features, if I wanted to list, it's a user-friendly interface, as I've been mentioned from the beginning. And you can work with the multiple layers. So the layer management is also easier, and the data import. So when it comes to data import, of course, you can add a different file formats, .tif file format, .csv, and all that. And the data editing also can be done. You can import from Excel file also, that can be done. And the plugins and extensions is another major advantage, added feature. And the spatial analysis, and then of course the geoprocessing they can do. And the data visualization can be done better. And the 3D visualization, you can also create a 3D map of a given area. So I'm going to show you how we can extract the building feature, the different type of building, like the industrial building there, and then education building is there, within the residential building also there. So for each type of building, we can able to develop a footprint, and that can be shown in the 3D map. So, and then web mapping also can be done, and which could be connected with your mobile applications as well. And then the Python console. So Python console. So this Python console will be useful for the better. Say example, we do the NDVI calculation, vegetation indices calculation example. So for all this, the whatever the input output that you're getting from this QGIS, that can be clubbed with the Python console. So which will do the better coding, and then we'll get a better output as well. So these are the added feature of this QGIS. And then, of course, this is about the QGIS. Yes, coming to the main topic of this session, that why civil engineers need GIS tools. Often we get this question. The GIS tools is, as I mentioned, it becomes essential. It's inevitable, indispensable part of our, in the development, okay, in the smart technologies part. So the GIS, which supports all part of decision making, of course, in all the part of decision making, in every stage of civil project. So maybe right from you're doing the planning and then design until the construction and management. Of course, post construction in the maintenance part also, this GIS tool will be effectively utilized. So examples are like mapping and analyzing the terrain and drainage in the water supply networks, and also we wanted to plan the road network. If we wanted to plan a road network from point A to B, so that can be done for the route optimization, and all this GIS tool would be useful effectively. And then water supply network to plan that, sewerage networks within the city, and then this selecting the site, okay, for constructing any of for doing any of the infrastructure development. That's that's very important part. So that's the very first step that we do. For that also, this GIS tool could be useful. And then monitoring the environmental and land use changes over the time. So how this land use, land cover changes is happening within the given locality. So that can be analyzed better with the help of this GIS tools. And then specifically, like we wanted to discuss within in the subdomain level with the civil engineering. So in the domain of surveying and mapping, this GIS tools is useful to plot the boundaries. So there will be, as an example, I wanted to plot the boundaries for certain study area. So that can be done with all the considering the administrative thing. With the geo tag, with the location base, with the lat, long values, all that, the boundaries can be created effectively. And then we do the georeferencing with the topos that's available. We can do that. And then we also do the contour. Contouring can be done with the help of the DEM data, that's digital elevation model data in the GIS. And you can integrate this, whatever the data that we do. Basically, if we do the survey within the area measurements or whatever, with the help of total station, that data can be integrated with the GIS, can be imported into it, and we can do the analysis of it. And the area and distance measurement tools can be done. And then in the context of water resources engineering, Maybe I think it's very much useful in the water resource engineering, like doing this watershed analysis part. So watershed delineation can be done, and then to identify the groundwater potential mapping. Um, I'll show you some case studies also on this, wherein my students have worked with this QGIS to identify how much the groundwater potential, how much the variation had happened in the Kanchipuram district for the 10 years duration. So, and also you can do the flood risk zone mapping. The flooding has become a serious issue nowadays. So to do this flood zoning, I mean zoning of the flood risk zoning, so that's very important to handle situation or to plan any of the infrastructure for that. Maybe that's very important to do that. This GIS is going to be useful. And of course, the drainage network analysis. Okay, so to get the connectivity and where it starts, where it ends. So, is there any obstructions in between? So, all that analysis can be done effectively using the GIS tools. And coming to the transportation engineering domain, this is very much useful in road alignment part and the road optimization segment as well. And also, if I wanted to design any of the signal system or any of the junction design, if I wanted to do, I need to study the traffic volume. So after studying the traffic volume, you can feed them maybe into the GIS uh, with all the relevant data. So will be useful in traffic density mapping. You can design the traffic junction in a better way. And then accident hotspot analysis. Maybe you can feed whatever the data that's been collected from the government or from the department, I mean police department or any other statistic department. You can feed all of them into the map, and you can able to visualize the data better, like where actually the major actions happening in the given within the given area of city limit. Maybe we can plan some, we can make a strict rules within the locality. So for an accident hotspot analysis, also this GIS tools is very much useful. And then urban planning and land use. So of course, this is very important. Nowadays, I think we often hear this term smart city or intelligent infrastructure in major discussions or in the newses. So so to do that, urban planning and effective urban planning and land use management, maybe this GIS tool could be useful. Land use, land cover classifications, like we can classify the vegetation, we can classify the water area, storage area, we can classify the residential area, and also we'll be able to see over the time how this urban sprawl has affected the land use, land cover pattern within the area that you're considering. So then the urban growth pattern analysis also can be done, and then infrastructure mapping. So that's also done effectively. And of course, the environmental engineering part, the waste disposal site selection, so the dump yards. To often we choose a dump yard location in maybe away from our the living area, living community. Even that the waste disposal site requires a lot of studies where you need to study the geological pattern and is there any near water localities, is there anything nearby. So all that details or all the study can be done effectively with the help of this mapping, I mean the geospatial tool, the GIS tool. So then the air and then noise pollution mapping can also be done. And then water quality analysis. So you can analyze the data that's been collected from the different locality. You can analyze the different water parameters, quality parameters, and you can feed them into the map, QGIS map, and then it gives a beautiful map, okay, or for the better visualization. So it would be like visually it's appealing. On the other hand, can also visualize the data better. So maybe you can do the better decision making using that. And whatever you see here, this map is created by my students, where we study, when we analyze the groundwater level in the Kanchipuram Taluk from 2010 to 2022. So over the time, how the groundwater level has been changed. Because in the last 10 years or 15 years only, there is the big leap of urbanization is happening within the given locality. So considering that, we had a thought to study the groundwater level, okay, in the given locality. So where we did this. This is August. This is a QGIS map that's developed for the 2018 duration, particularly for August month. So wherein we have fed the data which we collected from the Water Source Department, the Tamil Nadu government, and then using the data we have analyzed the collected data, and then we fed the data into this QGIS platform, and wherein we got this map. Okay, map. This was useful to to do the better. I mean, using this we will be able to analyze. So this dark blue color which indicates the highly stressed zone, water level zone. Here the meter MBGL means meter below ground level. So also we had analyzed the data from post monsoon and the pre monsoon, how the groundwater level has the fluctuation has happened within the given locality, and using that we mapped it, and we found that few locations like the Kanjipuram area, the main part of the Kanjipuram, and the Tirupurur region, and Acharapakkam, these regions are under the major groundwater stress zones, where because of the people often extract more amount of water considering the drought and other insufficient water supply from the domestic source. So we got some conclusion for our study. This QGIS map was very much useful. So using like this, you can do multiple studies. Whatever the data that you're collecting, and for whatever the study that you're doing in relevant to our society. Okay. Yes. So that's about how this JS tools could be made useful for civil engineering context. So then next we are going to discuss about digital twin concept. So we know what is digital twin. So digital twin is something, is a replica of what is the physical object that's there, or any of the system that you use, or any of the process that we manage. So that the virtual replica of these systems, or any of the process, which is continuously updated with the real-time data from sensors. Okay, so and other sources as well. So this digital twin, it acts like a living digital model. So wherein you are mirroring the real-time performance and behavior and condition of the real-world asset. Okay, so maybe to keep it simple, I would like to quote an example, maybe in this civil engineering context. Imagine you have a bridge. Okay, there is a bridge which is fitted with the sensors. Usually, this sensors which has a capability to record the stress level in the bridge, as well as the temperature changes over the time, and then vibration. What's the vibration that's felt because of the traffic flow on the bridge, and the displacement that's happening. So this digital twin of the bridge, maybe for this, like the digital twin of this bridge that we have developed, uses the real-time data that you are collecting from the sensor, will be useful to monitor the health of the bridge, okay, in the real time. Also, which would give us a notification, or to which predict the maintenance needs, whether is there any crack developed, okay, whether we need to patch that up now. So all that damage control can be done effectively with the help of this digital twin. And also you can simulate the different loading or environmental scenarios with the help of this digital twin. So of course the civil engineers can make a data-driven decision for a safety and performance, of course considering the sustainability aspect as well. So that's where the digital twin is very much useful. So this digital twin can be presented well, or it can be done better with the help of the GIS. So that's what I wanted to say. So this geographic information system and the building information modeling, we know that what is building information modeling. So all the powerful technologies, when both of them are integrated together, so which would contribute better for the development of any of the decision making, or any of the infrastructure management projects that we carry out. So yes, the digital twin is a virtual representation of any of the physical object or system in the context of the built environment. It often refers to integration of BAM and the JS data. So, so how this BAM, and when you're integrating this BAM and JS data, when you're integrating, how it's going to be useful? Of course, the data integration parts is going to be very much useful, and the spatial analysis can be done better. And then you can do the better asset management. Okay, it all made digital, so that you can access from anywhere. So also you can update it often whenever you are doing some, even the minor work when you're doing, or minor changes that can be done with the asset management. And of course we can do the real time monitoring. Okay, so in the project, and then this all this work will be useful in better decision making. And you can do collaboration, okay, with any third party. Suppose if you're offering the maintenance service to any of the third party agency, so you can include them into it, and then they can manage it better. So whatever happened before, they would able to study that, and based on that they can proceed with the further management. And of course, this is useful for smart cities and infrastructure development. And then emergency response and planning. This is very important. That's emergency response and planning part. So this digital twin is going to be very much useful for the better decision making. And also, we can do it swiftly, like without any delay, based on the situation that's there on the site, with the help of all the data availability, and the we can do the better decision making. Of course, this fusion of this BIM, the building information modeling, and GIS, which informs and fuels each other. Okay, the stakeholders as well as the decision policymakers. So it's like a win-win situation. So wherein we'll be able to do the better management and handle the situation. So which provides a real-time understanding of assets within the geographical context. And the key benefit, which includes we can manage the project life cycle better. Okay, so right from planning to maintenance. Okay, all this we can able to do with the help of this digital twin. And then also we can do the real-time monitoring, and also periodically you do the survey with the help of this UAV, that is unmanned aerial vehicles like drones or sensors. So we will be able to do the site scanning, and then whatever the data that's been collected from the drones, so that can be integrated with the system with the BAM, and then we can enhance the site management better. And then of course it is useful for the project lifecycle transformation. So when you're doing the data integration workflows to when you're doing the integration of data with the multiple levels, so which will be useful for the better for maintenance as well as the renovation process in the buildings. And then so this is also useful when you're doing the upgraded technologies like a 3D visualization. So for that also, this digital twin, integrating this GIS data, spatial data with the BAM, the building information modeling data will be useful. And then you can visualize that the given area in the 3D mapping, 3D maps better. Of course, this geographic information system, which handle the spatial data, which includes the map that we are collecting, even the normal map, and then the satellite imagery, and then geospatial data set. So this, whatever the information that we are collecting, we would integrate all of them, okay, into the digital twin. So this sets the geospatial context, okay, for any of the building project that you're carrying out, or any of the infrastructure that you're planning. So this, of course, when I'm saying the data and data and data, so which includes architectural features that you've designed, and of course the structural detailing of each and every part of the building or the project, and of course other branches or other domain of engineering like a mechanical data also could be clubbed with this, because that's all about the beam, right? So the electrical details, all of that. So this GIS tools that support the decision making by say that with the help of the spatial data that's already stored within, and also whatever the upgradations that you're doing often, so that it would give you the better output, and you can visualize the data better. So this by integrating this BIM data, building information modeling data, the decision makers can see the how, suppose if I'm implementing this project in real time, okay, in the site. So how this, whether it's going to be useful, whether it's going to affect any of the surrounding environment. So that can be sensed before you're constructing or before you're executing in the field itself. So you can simulate the various scenarios. Suppose if there is a flood happens, how the structure behavior would be, okay? Or if there is any landslide or earthquake happens, So how the behavior would be. So all that scenarios you can simulate, okay, within the software, and then you can plan the you make the structure resilient against all of this. So we can evaluate the impact of the design changes, and then this will be helpful to make informed decisions. So the GIS enables the spatial analysis, and also it's allowing the users to perform the geospatial queries, and which analyzes the relationships and also the visualizes the patterns within. So integrating this GIS geographic information system capabilities into the digital twin, which analyze, I mean, or which help us to uh, to do the better output, or to get a better output of the project that we're doing. So this, of course, this digital twin is a collaborative effort between the GIS and BM professionals, which promotes the interdisciplinary workflows. So without of much of the confusion, so they can work together simultaneously. They can implement. I mean, they can do their work without any of the lapses. So this digital twin, which will give us the complete view, I mean, the comprehensive view of the physical assets that we have, and the location, and then associated information throughout the life cycle with all the updated information. So this is very much important. Why I'm again and again I'm saying, or why I've included this digital twin topic into this role of QGIS means. So this is because nowadays the government almost worldwide, the governments are planning or implementing or constructing the smart cities. Okay, also they're doing the intelligent infrastructures. So for all this, to handle all this, I think this digital twin with the GIS is very much essential. So it allows us, it helps us, for the better management of urban space within, and also the considering the population density, okay, considering the restrictions we have within the developmental planning. So all that could be handled better with the help of this GIS data. So this digital twin can be used for the emergency response I've been discussing from the beginning. So by simulating the different scenarios as well. Okay. Of course, this GIS and BAM would be highly supportive to the regulatory agencies like CMDA. So they can monitor if there is anything like happening, like without any without any license or without permission. If any of the projects development happening away from their boundary, so that can be sensed better, or easily that can be found with the help of this GIS mapping. And of course, which will be helpful in zoning regulations and environmental standards to maintain these environmental standards and zoning control. So all that can be done with help of this. All this can be done better with help of the GIS tool. So at the outset, this integration of this GIS and the building information modeling, which empowers the users with a comprehensive and a dynamic platform that combines spatial data with the building information data that we have. So this integrated approach, which would allows the stakeholders to view better or to collaborate in the real-time manner, and then which would help us to do the interdisciplinary, to handle any of the situation better. Okay, with the interdisciplinary knowledge. So that's about the digital twin and the digital twin concept with the GIS. So now we will see a few case studies, okay, and also I'll take you to the QGIS software. Quick walkthrough. I'll show you that. So as soon as you open this, this is how the QGIS platform or the software would look like. So you can download this QGIS when you're typing QGIS in the web. So this would show you this. You can see this site. It's visible. So this is the official website of QGIS platform. So you'll be able to download the versions that you have. So this pop-up is. So you can download the different versions, okay, of the GIS software. In this, also you can see the plugins details, okay, and then so this you can download from this website. It the the size of the file would be around 1.2 to 1.3 GB. So you can download from this website for 62-bit or 32-bit, whichever system operating system you use. Accordingly, you can download. So as soon as you install this software, you'll be taken or you'll be end up in this type of interface. So this QGIS interface, in the top you see this is your menu bar. As almost you have 13 tabs like a project, edit, view, layer, settings and plugins. Of course, the vector data, you can manage the vector data, and then you can manage the raster data exclusively with this tab. The database, web, mesh and processing. And if you need any inquiries, if you have any queries that you can raise through this help thing. And also you have the horizontal toolbar, and then you have the side toolbar. And when you're right clicking it in the mouse, you can see this. If you wanted to add any of the toolbars additionally, suppose the database toolbar, that I can add. So all the maybe accommodating all these toolbars within the given space is difficult. So whichever the toolbars that we require, so that can be chosen and can be kept in the interface. So, and then this is your status bar. In the status bar, in the bottom line, you can see there will be a coordinate, there is a scale, and then magnifier will be there, and the rotation, and the CRS also will be there. CRS means coordinate reference system. The coordinate reference system, which means like the UTM Universal Transfer Migrator, and then WGS, and other local projection systems. All the details will be mentioned which coordinate system that you're utilizing, using. So this is EPGSC is a example for the conical map projection system. So that's about the interface. Maybe you can start with a new project, or you can also do the new empty project. I can open this new empty project. So now I'll show you the forest fire prediction. Okay, so first I'll take you through the how we can predict, how we can analyze the forest fire that happened in the Los Angeles area in the 2025, some few months back. So for that we need a data set, okay, to feed in. So the data set was downloaded from USGS website. That's an open source. I mean, that's a free accessible website. You can download that, the data set from this USGS. You need to have a login. You need to create a separate login to download the data. Okay, so this would ask as soon as you log in, this would ask for certain details. Okay, so about the data that you are interested to download. So you need to feed the data. Once you feed all of them, all the required details, the data set will be ready to download. Okay, so I have already downloaded the data because maybe it takes a little time to do it. So considering the restriction of time I have, so I've already downloaded the data set. So I've downloaded the data set like for before the forest fire that happened, and then also I've collected the data. The data in the sense I've collected the satellite imagery, okay, from the Landsat series. I've collected the satellite imagery of that particular study area, the Los Angeles area. So I've collected around 7 maps that I've collected from the Landsat data set. So this we will feed them into the QGIS software, and we'll see how this data set useful in predicting the forest fire. Okay. So what I'm going to do is also you can see I've downloaded data for post forest fire as well. So in the layer, what you have to do is first, as soon as you create the new project, you go to the add layer. In add layer, so this satellite image is like a raster type. So we'll do the raster imaging, and then you click on this three dot. Okay, so as soon as you click on this, you will be able to see the folder, the job. So I'm gonna. It's a very simple way of doing. It's just you have to add all of this, the data that's been downloaded. You can close them now. Close the tab now. So as soon as you add this data set, so this gives this would be visible in the working area, workspace. It's a map visualization area. Okay? And in this now, what you're going to do is we're going to club them. I mean, now I've downloaded the seven different images, seven different satellite imageries. So now I'm going to club all of them. I'm going to merge them using the merge option. So for that, I have to go to the raster. So basically, this is a raster type. And then within that, under the miscellaneous option, I'm going to choose the merge option. In the merge option, you click on this, and then I think you can able to see all the seven images. So I'm going to select all of them, click OK. Okay, and then place each input file into the separate band. And after choosing this, you have to run this. So it takes little time, like 30 seconds to 1 minute to combine, to merge all of the data. And if you wanted to learn QGIS, it's easy, of course, because there are a lot of tutorials available on the YouTube, and there is a course also, a free course available in the Coursera given, which was produced by L&T Tech. Because these type of skill sets are it's highly in demand nowadays. So it takes few seconds to complete. So on this side layer, you can able to see the different data sets. All those seven images have been in there. The band, in the sense, the contrast level, the band. Basically, these are all like remote sensing data, electromagnetic radiation, the wave. So we have rays starting from X-rays to radio waves. So each of them, like based on the wavelength, there will be different bands. Okay, so now the process has been completed. All this seven layers been meshed together. And as soon as it's been merged, you can see, there is a change in the color because all of these images been merged. And you can see this is, there are band 1, band 2, band 3. I'll tell you all what it's that. And after, once you merge all of, once the merging is done, go to the properties. Under the properties, choose a symbology tab. And under the symbology tab, you have to choose a multi-band color. So in the multi-band color, I'm going to choose band 2, that's a red band. And then green band, I'll keep it as 3. And then this is a 4. The blue band will be like a band 4, I'll keep it. So brightness level, I'm just adjusting it to 10. So a little bit minus 70. The contrast level, I just treat this as 10. And now you can see there is, once you fix this, you can apply them. Okay. And you see this. Okay. So band 2, band 3, and band 4. You can visualize, maybe I would change the color so that we will be able to see them better. So you can see those green color patches. Set on. Let us adjust the contrast level. Maybe 90. This is 8. This can be taken to 12. This is 20. Right. So you can see the forest areas with the green covers, of course, with the light. And so now it's been processed. The given area is processed. The satellite image is been processed. So once the merging is done, okay, so what we can do is go to the extraction, go to the clip raster by band, and then you can choose from this the merge layer that you're going to do. So now you can see those with the, if you're choosing a different band, say example, maybe in the post fast file, I'll choose a different band, you would see the difference, okay, how the color changes happening. I mean, that would be helpful for the better visualization of the given study area. Okay. So now if I wanted to see that particular portion alone, maybe what I will do, I'll just deselect the remaining layers. So this is what I meant working with the different layers. I will just opt out. Only you will see the particular region wherein you have, in which portion that you are interested in. Say, I assume the forest fire has happened in this particular locality. So I would deselect. Again, I'm just selecting all of this layer too. So now I'm just going to export them, export this particular image as before forest fire. Okay, so you can see the usually these images and all will be stored in the GeoTIFF file. I'm not sure the GeoTIFF file is cannot be opened in the normal image viewer. This the QGIS and other JS software is compatible to see this image. So okay, so now the image is being stored, and then as soon as you store this image, the before forest fire thing is being saved. Okay, so this is, so now we have clicked this particular region alone. Now we'll see the forest forest fire. Maybe we'll see this. I'm gonna add layer. So now this, you can do this the forest fire study after also that can be done with the same page, but just wanted to show you how this would look differently when you're doing. So the raster. Now I'm going to do the analysis for the same steps only to be same steps to be followed, even to create to visualize the after fire, after the forest fire. So what I'm going to do first, just go to the layer, add layer. In add layer, go to the add raster layer. In this, I choose this. Now I'm going to choose the data of after fire. So just open them and click add. So make sure all the images been included in the topics. Now the same steps to be followed. Go to the miscellaneous, go to the merge, and choose all of this. Thing. Only 6 images. 6 images have been included. That one. Maybe if there is anything like happen, like mistake, you can delete them. Also, you have a flexibility to delete. You can remove the layer. So I'm going to add. Now this one, just go to the raster, miscellaneous, merge, this select all, then facing. Maybe takes seconds to complete. And maybe in the meantime, I'll tell you the other about the plugins. Okay, now the process has been completed. So now what you can do is, now the merging has been done. Now we have to go to the merged, and then go to the properties, choose the multi-band color, and then band 3 is for red band, band 4, and then band 5, choosing it for blue band. And then here, choosing -80. This is 10. Just apply. Hope we can clearly see this, the area that's affected with the forest fire now. Maybe that can be seen even better. Extraction, replaced by the extent, and then we're choosing merged. extend. Now you can see this area, the forest area, fire area, which is affected with the forest fire. Okay, so this is how it's useful doing the analysis. Could be a forest fire or it could be a landslide. So whatever the thing that you're considering, so that can be visually that can be extracted better for the better decision making as well as for uh, better management. So this can be now exported and then keeping it as after forest fire. So here it's okay. We can able to see the area which is uh, affected with the forest fire. Hope it is clear. It's very easy to do. Okay, so this is how this QGIS could be utilized in doing any of the doing analysis on forest fire study or landslide study. Even if you wanted to study the flood affected areas within the city, so that also can be done effectively with the help of this QGIS tool. It is clear. Any doubts or clarification? Next, we will see about the building footprint extraction. That's going to be interesting. It's also very much useful for for our domain. In building footprint extraction, uh, you can classify. I mean, you can do the residential building. You can extract the data better. I mean, you can create a map of the uh, residential building separately, and you can create a map of the industrial building separately. And then already the residential. I mean, with the different type of buildings, the footprints can be mapped and then can be viewed in the 3D view. So that's what I'm going to do now. So to do that, I'm going to use this plugin called OSM. Okay. So it's already I've included that plugin within. To create a new project under map, you click on the quick map services under that OSM, then OSM standard. As soon as you click this OSM standard, you'll be seeing the entire. This is one type of projection system. So I'm going to choose area within this. And you may choose whichever the area you feel. I just wanted to show you the multiple building types, so that's why I'm choosing the area here. Choose the area of Oklahoma City, which is in US. So after you can see this is thickly populated area with different type of, I mean, with the dense population. So to do this analysis, what I'm going to do is I'm going to choose this here. This building. I'm choosing building apartments. So I'll choose this Canva extent, run the query. So now, maybe if before and after, like before running and after running the query, you can able to see the buildings, okay, the apartments, which are all highlighted now. Okay, that's the separate layers alone. It's been demarcated with the help of this. Okay. And the same way, you also can do it for normal building a house. Of course, I mean buildings with a industrial building we can do. Okay. Can run a query. If it is there, it would come. Otherwise, it would add. Now we can see these are all residential building apartments. And now the new layer has been added. It's been included. So this is a industrial category buildings, okay, within the area. So after this, what you need to do is you can go to the properties under the symbology. Maybe you can uh, for industrial building alone, I gave a separate layer. Okay, for better color contrast, I've changed. And maybe if I so that you have to choose this particular option called single symbol, and then maybe if I'm choosing the apartments, I can run this query. So this apartments. Now, if I'm choosing this building apartment, in this I'm going to choose a property. And for this, going to add this outline pattern like this. So now this residential building apartments have been marked with the different layer. Okay. And now you see in the given locality, the industrial buildings have been marked with this level, and then this is a residential building. It's clear. What next time? What I'm going to do is I'm going to do this in the 3D view. Just I'm going to create a 3D map. And before that, you have to go to the properties. You need to fix the location first. Yeah. So after that, we need to choose this CRS. So in the CRS, this coordinate reference system, that should be selected appropriately to get this. Um, so in that I've already chosen this Oklahoma North coordinate reference system. So just apply that. And you need to do that. You have to confirm that projection. And give OK. So once you choose this in the given area, next you go to the view. Okay, and then new 3D map view. Yes, error. just got stuck. Okay. Just to so after that, what would happen? Like once you give the proper coordinate reference system, we'll be able to see the building, extrusions. Okay, extrusion in the 3D view. You'll be able to see the extent of the building in the given study area. Maybe you can do it for a smaller area for the better visualization. Do it. Just a minute. Maybe open it again. So this building footprint, studying this would be useful. Here I've already done this. Okay, for a particular area. Just a minute. Spot on. This building footprint study is quite useful in smart city, in the city planning and to control the urban infrastructure development with a different classification of. So this here, let's see, view. So you can see this view of the building. It's along the footprint of the buildings alone. Okay. So this you can change the color and all this, the even those changes and all can be done here. Also you can change this. Particular. So hope you have seen this 3D. So this is how the 3D mapping of building footprint can be created with the help of this QGIS software. Okay, so that's it. These are all my references. Any doubts? So that's it from my side.
Participants, if you have any doubts, you can clarify with sir.
And this building footprint studies and all is quite useful uh, in the it's an important part in the smart city planning. Okay, if, we're able to refer to recently I've gone through some of the reports in the newspaper in that mentioned that they've been using the JS tools and all to know the already developed infrastructures within the given space. So to know all of them, like with the different categories of buildings, to know that maybe this will be quite useful. Okay, if you're keen to learn about QGIS software, as I've already mentioned, there are a lot of tutorials available on YouTube's, which is all free, and also there are certain agencies, private agencies, who are all offering the course on JIS. Few of them are paid, and if you want to learn the basics, those options